Good morning, all. Welcome back to the next lecture. Having discussed the details of graph, especially in a linear function, we are now getting into the applications of graph in economics. See, economists are often interested in geometry and they make use of geometry in order to simplify very abstract ideas. Otherwise, it would be a Herculean task for the economist. See, these graphs are considered as a powerful tool for economics, which facilitating the analysis, communication, and decision making by providing a visual representation of economic concepts and data. Therefore, today we will discuss how economists often use these concepts in their day-to-day business. Some of the far-reaching implications of linear equation and their straight line graph are very abstract ideas of consumer and producer behavior analysis and consumption function. From the consumer behavior, you might have been aware about the concept of budget line, and from the producer behavior analysis, the Isocost line as well. So today we are going to discuss how to draw the budget line and Isocost line. See, in a consumer behavior analysis, a linear curve is used to express how rational consumer will allocate his money income to consume different bundles of commodities available to him at a particular price and time period. And this is a linear curve and what we can call as a budget line. So I hope everybody is aware about this concept which might be studied in microeconomics. So let me repeat it again here. The budget line is known as, it is either budget constraint or price consumption line, which actually represents different combination of two commodities that a consumer can afford given a fixed amount of income and the price of commodity. That is, with a given level of income and the prices of commodity, how much amount of quantities of two commodity that a consumer can buy by using his given income. So let us assume a consumer has a money income of M unit of money income, and he wished to purchase two commodities, that is commodity X and commodity Y. And the price of these commodities are also given. That is, Px is denoting for the price of X and Py is denoting for the price of commodity Y. And if the consumer is wish to spend his entire money income on purchase of these two commodities, then this relationship can be expressed mathematically. See, it is price of X, Px plus Py Y, which is equal to M. Px is the price of commodity X. How many units of commodity X you are going to purchase? Py is the price of commodity Y, and how many units of commodity Y you are going to purchase, and M is nothing but it is your total money income. So geometrically, we can plot this budget line if we take the commodity X on the X-axis and commodity Y on the Y-axis. See, but it is not an easy task because we already saw that plotting an equation into a graph require a proper methodology. So first we will find two extreme points of the budget line, which we are generally known as it is X-intercept terms and Y-intercept terms. So here we are assuming that when it comes to the extreme point of the budget line, it is nothing but the two intercept terms are here. See, by assuming consumer is not purchasing one commodity. See, we can find the two intercept term in such a way that by assuming that consumer is not purchasing one commodity, that is, we are arbitrarily assuming one coordinate value as 0. For example, in order to find out the x-intercept, consumer is spending his entire income on the purchasing of commodity X, and he is not purchasing any single unit of commodity Y. Then we can derive here, see, by this is our budget line, that is price of X into X plus price of Y into Y, which is equal to M, that is his money income. Then we are assuming that he is going to spend his entire income on the purchasing of commodity X by assuming Y is equal to 0, that is he is not purchasing commodity Y. So this Py into Y term will become 0 if you go for substituting Y is equal to 0. Then what is remaining here? The price of X into X is equal to M. So if you isolate X here, then we can divide the both side of the equation by price of X. Then price of X in the left hand side will be cancelled out, and M divided by price of X. It will become, in the right hand side, it will become M divided by price of X. So when Y is equal to 0, then X is equal to M divided by price of X. And this is nothing but, this is the x-intercept term. Similarly, the y-intercept term can also be calculated by assuming the consumer is spending his entire income on the purchasing of commodity Y, and he is not going to purchase any single unit of commodity X. So here we are assuming, that is, our budget line is price of X into X plus price of Y into Y, which is equal to your money income. Then assuming X is equal to 0, that is he is not going to purchase commodity X, then if you put this X is equal to 0, then Px into X term will become 0. Then Py into Y is equal to M. Then if you divide the both side of the equation by Py, we can isolate the Y as well. So Y is equal to Py divided by Y and M divided by Y. That means in the both side of the equation we are going to divide with Py. So Py will be cancelled out, and what is remaining here? Y is equal to M upon Py. And this is y-intercept term, that is, by assuming X is equal to 0, the y-intercept will be M upon Py. Now we received the both intercept terms, that is the coordinate points here, it is M upon Px when Y is equal to 0, then M upon Py when X is equal to 0. So we got the two intercept term, and these two intercept term are nothing but it is the two coordinate points. And here we are going to draw the graph, see, by taking the commodity X on the x-axis and commodity Y on the y-axis. Then we will plot these coordinate points on the graph. See, M upon Px when Y is equal to 0, when Y is equal to 0, X is equal to M upon Px. I am denoting here an arbitrary point here. Then I am considering the second coordinate point, that is M upon Py when X is equal to 0. So when X is equal to 0 here, our Y coordinate is equal to M upon Py. I am denoting the point, arbitrary point here. Now by joining these 2 points, we will get a straight line curve, and this is nothing but we can call as a budget line. And this budget line showing that the maximum amount of commodity X and commodity Y that a consumer is able to purchase by using his given income and also the given price of commodities. So here the position and the slope of the budget line is determined by the consumer income and the price of the two commodity being considered. And the intercept of the budget line in the both axis is representing the maximum amount of the quantity of commodity, each commodity that can be purchased when all income is spent on the particular commodity. Now let's see, we are going to find a linear equation from the given budget line, that is budget line in linear equation format. See, we know the budget line in terms of mathematically, see price of x into x plus price of y into y is equal to m. So now this equation can be transformed into a conventional linear equation by solving our equation for y, so that it will become a linear format. So as we discussed in the previous lecture also, by convention we will be expressing a linear equation for the dependent variable. You know, we need our equation in relation with y. So we keep the py into y in the left hand side and taking price of x into x into the right hand side of the equation. So it will become, see, the sign of the price of x into x in the left hand side of the equation was positive. So when you take into the right hand side, it will goes to the negative sign. So it will be negative price of x into x. Then we will keep y value in the left hand side and then we divide the both side of the equation. See, here we will divide the both side of the equation by using py. So since py is in the multiplication form, we will divide the both side of the equation by using py. Then we will get, you know, y is equal to m minus price of x into x into 1 upon py. So we can divide the each and every element in the right hand side of the equation by using py. Then y is equal to m upon py, then minus price of x divided by price of y into x. By rearranging the final format, we can write y is equal to m upon py minus price of x divided by price of y into x. See here, the m upon py is the intercept coefficient, or it is the intercept term. That is, if x is equal to 0, then y is equal to m upon py, because when x is equal to 0, this entire term will become 0. And this price of x divided by price of y is nothing but it is the slope coefficient. So m upon py is the intercept term and minus price of x divided by price of y is the slope coefficient. And the slope of the budget line actually reflect the relative price of two commodities, and it is calculated as the ratio of the price of one commodity to the price of another commodity, which means that in order to obtain an additional unit of commodity y, how many unit of commodity x must be sacrificed. So after converting the budget line into the linear format, we are going to consider some numerical examples so that it will be more clear. So let me look at a numerical example. Suppose we take a hypothetical consumer who has a daily income of 800 rupees. Clothing. There are two commodities that he wants to purchase. One is food and another one is cloth. So the price of food, PF I am denoting here, it is nothing but it is the price of food which is equal to 100 rupees per unit. And the price of clothing, that is equal to 200 rupees per unit. So PC I am denoting here price of cloth. So we want to find out the budget line here. And by using this particular information, we can make a table which showing that various combination of food and cloth, the various combination of food and cloth that the consumer can purchase each day with or by using the income of 800 rupees. So we have a different combinations are given. If he spend his entire income on the clothing, then we have 4 unit of cloth can be purchased because the price of cloth is equal to 200. So 200 into 4 which is equal to 800. 800 is the constraint here because he is having only 800 rupees to purchase both commodity. So at that particular point of time he cannot able to purchase the food. So in the similar way, if he purchase the combination B or the basket B, he can go for 2 unit of food and 3 unit of cloth by using the 800 rupees of income. If he go for combination C, then he can purchase 4 unit of commodity food and the 2 unit of cloth and by using the same 800. Similarly, the D, combination D as well. Now see the combination E. At this particular point, we can say that he is spending his entire income on the purchasing of food, which is 8 unit. So 8 into 100, which is equal to 800. So at that particular point of time, he is unable to purchase the clothing. So his entire income is spending on the purchasing of food. So algebraically, see, this is point E is the one intercept term and A is the another intercept term. And algebraically, we can also calculate the x-intercept, which is the ratio of money income, that is M divided by the price of x. So it is M upon price of x, which is equal to, this is which we are already derived earlier. So M is here 800 and price of x, we are assuming it is price of food. So it is 100, so which is equal to 8. So here this is considered as the combination x. When y is equal to 0, that is clothing is equal to 0, then the how much unit of commodity food can be purchased, it is 8 unit. Similarly, we can also calculate the y-intercept term. It is also the ratio of money income to the price of commodity y. That is, here we are assuming it is the food. Sorry, it is clothing. So here it is 800 divided by the price of clothing is equal to, it is 200, so which is 4. So when x is equal to 0, that is food is equal to 0, then clothing is equal to 4. So this is the another intercept term. So when x-intercept is here, it is 80 and y-intercept is here, it is 0 and 4. So once we get the x-intercept term and y-intercept terms, see, we can plot this table very easily into the graph. So this is our different baskets. See, we have a two axes on the Cartesian space, that is x-axis and y-axis, which is displayed here. We are taking the food on the x-axis and clothing on the y-axis. And then let us mark two intercept on the graph. See, one intercept is 0, 4 and another intercept is 80. So here we are taking the point E, that is x-intercept term, by assuming clothing is 0. So here it is 80. 80 we are marking here at this particular point. Then the second y-intercept term, that is the particular budget line is crossing the x-y axis, that is y-intercept term is A, that is 0 value of food but the 4 unit of clothing. So this is the y-intercept term. So after getting the x and y-intercept term, see, we will interconnect these points with a straight line. So this is the straight line which we are using. We will get a budget line here, and the different other points are, see, the combination B, arbitrarily I am putting the combination B, it is 2 and 3, 2 unit of commodity X and 3 unit of commodity Y, and similarly the combination C, 4 unit of food and 2 unit of clothing, and point D, it is 6 unit of food and 1 unit of clothing. So we have a proper budget line here, and see, we have a point outside the budget line, that is point G. See, this point G is outside of the boundary of budget line, which is generally assumed as it is unattainable. It is not possible to purchase at the point G because consumer income is limited. And similarly, we have the point F also, which lies within the or inside the budget line, showing the consumer is not spending his entire income for consumption of this commodity. See, he is now purchasing only 2 unit of commodity, C, commodity food, and then 1.5 unit of cloth. But at this particular point of time, what we are assuming, consumer is not spending his entire income on the purchasing of the both commodity, that is food and cloth. So however, there are certain situations where the budget line curve shift or we can rotate it. How it is possible? See, when the consumer income is changes or the prices of food and cloth is going to change, then in these two situations, budget line will be shift depending upon how your income is changing. If the, for example, an increasing income will shift the budget line outward parallel to the original position. So we have the original position, this one have a parallel curve if the income is going to change. And changes in the price level, it also leads to the changes in the budget line. So changes in the price of commodity will also rotate the budget line, and which will affect the slope and altering the relative affordability of the commodities. Okay. Now, we can calculate the slope from the budget line. What is the slope of the budget line? See, the budget line, we have the price of x into x plus price of y into y, which is equal to our total money income. So, the budget line equation we already transformed into the conventional linear equation format by solving our equation for y term. We are solved or transformed our equation for the y term. So once we solve the equation for y variable, our budget equation will be in the form of y is equal to m upon py minus price of x divided by price of y into x. See, we are already discussed m upon py is the y-intercept term. That means when x is equal to 0, then y is equal to m upon py. And minus price of x divided by price of y. See, it is the slope coefficient. It is the slope coefficient, that is minus px divided by py, that is price of x divided by price of y. And solving the slope coefficient by substituting the price of x is equal to 100 and price of y is equal to 200. Because we are assumed in the previous example, the price of x is equal to 100 and price of y is equal to 200. So by substituting these two values on price of x and price of y, then what happened? We will get a 100 divided by 200, which is equal to 1 by 2. If you solve it, it is 0.5. And what it shows? It shows that for purchasing of an additional unit of commodity X, if you want to purchase an additional or extra unit of commodity X, then we need to sacrifice 0.5 units of commodity Y. This is nothing but it is an opportunity cost. It is an opportunity cost of an additional 1 unit of commodity X is 0.5 unit of commodity Y. This is the interpretation regarding this particular answer or this particular solution. So this is regarding the slope of this particular budget line. Now consider the isocost line. See, being discussed the budget line of the consumer, now we are getting into the similar concept that usually economists used to analyze the producer behavior. See, in this case, which is generally known as isocost line, and the entire concept is related to the budget line of the consumer is same here also. But the difference here is that, see, we are concerned with the total expenditure or total outlay of the producer, and instead of the commodity, we are considering the bundle of the factors of commodity. So we are showing that isocost line is the maximum amount of two factors of production that producer can purchase at his given outlay and at the same time the given price of factors of production. Let us assuming that producer is only purchasing two factors of production. One is labor and another one is capital. And there exists a specific name for the price of factors of production. For the labor, we are giving the wage rate, and the capital, we are providing the rate of interest. So accordingly, we can write our isocost line mathematically, that is WL plus R into K, which is equal to C. So here W is the wage rate, L is the labor, then R is the rate of interest, K is the capital, and C is the total outlay of the producer. Now we can find the intercept term of an isocost line. See, we can find the both x-intercept term and y-intercept term by using given isocost line. See, to find x-intercept and y-intercept of the given isocost line, see, by using this particular WL plus RK, which is equal to C, we need to determine the point where the line intersect x-axis and y-axis respectively. See, in the case of x-intercept, we are assuming K is equal to 0, that is capital is equal to 0. Then what happened? To find the x-intercept term, we are setting K is equal to 0 and then solve for L. So here putting K is equal to 0, then it will become WL plus R into 0, which is equal to C. So this term will become 0, WL which is equal to C. Solving for L, then it will become CW. So this is the x-intercept term. This is the x-intercept term. So therefore, x-intercept term is here C upon W when y is equal to 0. Similarly, we can also find out the y-intercept term by assuming labor is equal to 0. So to find the y-intercept term, we are putting L is equal to 0. So in this particular Isocost line, we are putting L is equal to 0. So W into 0 plus R into K, which is equal to C. So C is the total outline. So we can simplify it. RK is equal to C. Isolating K here by dividing the both side of the equation by using R. Therefore, we will get K is equal to C upon R. So therefore, we can say that y-intercept terms are here when x is equal to 0, that is here when labor is equal to 0, then our y-intercept term will be C upon R. So these intercept represent the point where the Isocost line crosses x-axis and y-axis represented respectively. Now we are going to make the graph of this particular Isocost line. See, we have a coordinate which we are already calculated, C upon W when y is equal to 0. So this is the one coordinate x-intercept term and this is the y-intercept term. So here we are taking labor on the x-axis and capital on the y-axis, and then we are marking the coordinate points here. C upon W at this particular point, it's an arbitrary point when capital is equal to 0. And similarly, by assuming labor is equal to 0, we can plot here it is C upon R. C upon R by assuming labor is equal to 0. Now after marking these 2 points, we can join these 2 points together and then we will get what we can call Isocost line. This is the Isocost line. But the position and the slope of the Isocost line, which is entirely determined by, it is producer income and the prices of 2 factors of production. So here, the intercept of the Isocost line, that is in this particular points, this C upon R and C upon W, which is nothing but it is the maximum quantity of each factor, that is labor or capital, that a producer can purchase when his all income is spent on the purchasing of particular factor, that is either labor or capital. Now we are deriving the linear equation from the Isocost line. So Isocost line in linear equation format. See, in our equation, we can rewrite our equation, that is WL plus RK is equal to C in a linear format, y is equal to A plus BX. This is the linear format for solving or isolating for K. So here we are keeping RK here left side and WL we are taking into the right hand side of the equation. So it will become minus WL. Then dividing the both side of the equation by using R, then we can isolate K here, then C upon R minus W upon R into labor. So here we will get the linear format of the Isocost line, that is K is equal to C upon R minus W upon R into L. Now equation is purely a linear equation here. And C upon R is the intercept term, or it is the intercept coefficient. W upon R minus W upon R is the slope coefficient. And the slope coefficient of the Isocost line is negative value. Of course, it is because if you want to increase the consumption of one commodity or one factor, or if you want to employ the factor, then we need to decrease the another factor. So this is considered as an opportunity cost. Consider one example. Suppose a firm has ₹600 to spend on labor and capital factor, and the price of labor is equal to 40 per hour. Then price of capital is 50 per machine hour. So we want to construct the Isocost line. So what are the various possibilities here? I am establishing here an input-output table by using this given information. See, his entire income outlay is equal to 600. So by using the price of various factors, see, he can purchase 12 unit of capital, but at the same time he is unable to purchase labor by using his given 600 rupees of income. Or he can use the combination B, where 5 unit of labor and 8 unit of capital he can purchase by using 600 rupees. Or he can also purchase the C, 10 unit of labor and 4 unit of capital, and D, it is 15 unit of labor. At that particular point of time, he is unable to purchase the capital. He is only using the labor. Okay. Now, by using this particular example, we can derive the x-intercept term and y-intercept term. See, these are the various coordinates here. So, here when labor is equal to 0, then capital is equal to 12. When capital is equal to, labor is equal to 15, capital is equal to 0. So, we can calculate the x-intercept term, that is C upon W, which we are already estimated earlier. So, see here the total expenditure, which is equal to 600 divided by 40, which is equal to 15. So, when here the capital is 0, then we can find the x-intercept term, that is 15, 0. Similarly, we can find the y-intercept term as well, which is C upon R, that is 600 divided by 50. So, it is equal to 12. So, when x is equal to 0, then y-intercept term is equal to 12. So, by using these two intercept terms or by using the different coordinate points, we can draw the graph. And see, here on the x-axis we are taking the labor and on the y-axis we are considering the capital. Then we are going to plot these lines. See the point D, it is 15 when x is equal to 0, capital is equal to 0. When labor is equal to 0, then capital is equal to 12. Now, by joining these two lines, we will get an isocost line. This is an isocost line. The remaining points we can mark at point B, it is 5 and 8, point C is 10 and 14. So, 10 and 15. So, by using this particular isocost line, these are the various possibilities or possible purchasing of the commodity that a particular producer can purchase by using his given level of income. So, consider a point here, point F, which cannot be purchased because it is beyond the boundary of isocost line. By using the producer income of 600 rupees, he is unable to purchase this particular point. And similarly, if any point inside the isocost line, it is feasible, we can purchase it, the producer can purchase it, but he is not spending his entire income on the purchasing of the two factors, that is labor and capital. If he spend his entire income on the purchasing of two factors, so he will lies on the given isocost line. So at this particular point, he is spending his entire income on the purchasing of labor, and at this particular point, he is spending entire income on the purchasing of the capital. So at any point below the isocost line shows the combination of capital and labor that producer could purchase, but without spending his entire money income. And similarly, at any point above the isocost line, that is the combination of both labor and capital, but it is unable to purchase by the producer by giving his given total outlay. So let me conclude here. In this lecture, we discussed some of the application of graph in economics, especially budget line in consumer behavior analysis and isocost line in producer behavior analysis. In both cases, we derived the intercept term and drawn the graph, and also found how to transform this particular given budget line and isocost line to a linear format as well. So I hope it was clear to you, and we will see in the next lecture. Thank you.